All right. Thanks. Yeah, I hope everyone can hear me all right.
You sound great.
Cool. Yeah, my name is Kyle Stover. I'm a silviculturalist on the Superior National Forest out of Tofte, Minnesota. And what this is a case study we submitted to the Great Lakes Silviculture Library about a year ago. But it's looking into one of our earliest examples of using a variable treatment to increase stand complexity or preserve stand complexity. And I like it because, I think it's really interesting in integrating the research into on-the-ground applications, but it has represented a really nice kind of storyline of how we've been incorporating this over the last 10 years or so. So why are we doing this? You know, around the early 2000s, we were starting to see more research out of the Pacific Northwest in particular of how to increase more complexity into our management strategies. And, you know, this isn't just to the Northwest, but also locally as well. We get a new red pine manager handbook for the North Central states. And I thought it was really unique in there at this point in time. We're starting to talk about how to increase complexity in regards to red pine management, and has really shown how our research and understanding has been growing. And around the same time, the Superior National Forest Plan is coming along and really relying heavily on research from ecologists like Lee Freilich about the natural range of historic variability. And now we're seeing these this research transition into some actual objectives for our management. So within that forest plan, restoring structural diversity and ecosystem processes within management is starting to become as a management direction. And then by the time this forest plan is starting to really integrate with a lot of our forest vegetation management projects on the forest, the 2E vegetation management plan that occurred on Tofte have some of the earliest uses of this weird bin treatment that we have started applying to stands called variable thinning. So that's an incomplete history, but I really do think this has been a process oncoming with coming available research. So the sale I'm going to be talking about that we're doing this case study on is the Northeast Timber Sale. It's about 12 or so miles inland from Tofte and Lutsen, Minnesota, up in the very northeast corner of the state. And it is a 50-acre mixed pine stand from 1908. All the records I have that it is natural with no records of previous management. But you know, when you look at the overstory structure from our pre-cruise and stand exam data, we're really looking at a true mixed pine stand that's dominated by red pine, white pine, but also a very heavy component of paper birch, cedar, white spruce, jack pine, and a balsam fir. And you know, this isn't, for a pine site in northeast Minnesota, this isn't that unlikely from what I would expect in a natural stand. And this would contrast more from what the research the research examples we may get out of areas like the Chippewa or the Kutfit Sioux experimental forest. So it leaves us with the question of what to do, because it doesn't always fall into the exact cover type options that are available to us in the manager handbooks. And soils also show that, you know, we're looking at a fine sandy loam cap over gravelly loamy till. It's well drained. There's a lot of variable slopes out there with a relatively high rock content. And its NPC classification is FDN 43A. So how did this management direction get translated into a prescription? So the overarching silvicultural objective was old, large diameter mixed pine stand with both structural diversity and species diversity. And we really wanted to maintain that on the landscape in this older stand. And also, a silvicultural objective was to maintain this overall pine patch by mimicking the role that mixed severity fire may have played in this FDN 43 system. And how this translated into a prescription was we chose this variable thinning prescription. And just by the mix of species that were out there, we try to make it as simple as possible. So harvest the merchantable hardwoods, which was mainly paper birch, but also jack pine, spruce, and fir. Reserve all white pine that were out there, and then cut tree mark the red pine to an overall residual density of 80 to 90 square feet of basal area. And a secondary treatment, we wanted to introduce a prescribed underburn to reintroduce fire back into this ecosystem. And because it was binned as a thinning treatment, we did not prescribe a regeneration requirement with that prescription. And you can see from the layout is it was a pretty funky due to its surrounding vegetation and the character of the site itself. It doesn't get much more amoeba than that. And what actually happened? Well, it was cut in the winter of 2011 to 2012, which was a very low snow year. And just based on the spatial arrangement of the species out there, it was kind of hard to predict initially, unless we really mapped the site better. But we wound up with larger gap openings than we initially expected from those hardwood pockets. And they ranged from anywhere from a ½ acre to 3 acres in size. And due to slopes and again, to slopes and the amount of hardwoods we were able to cut out, we ended up with less overstory density than we anticipated on the stand average basis. And that came out to be around 66 basal area in 2019 measurement. And the prescribed burn was dropped, and there was a lot of debate around that decision at the time. That's not universally held among our whole team, to be very honest. But I think some of the rationale for that was because of this oddly shaped from an operational standpoint of burning it. We wound up with less overstory density than we thought. So I think there could have been some valid concerns about any additional mortality. But this one wasn't after we went as far as putting in some dozer line and did some balsam crushing out there. And in 2013, TNC came along and we were looking for some study sites for an assisted migration study, planting bur and red oak that they had going on. And we thought some of these larger gaps would provide a rationale to do so out here, and also help us fulfill some of our regeneration requirements since we had such big gaps. So I'll do a quick picture tour, just kind of skipping across the stand here. One of the things, you can't really grab a picture that captures the entire site, but there are areas that were heavier to a brush response. And I really like this perspective because it does really show we did achieve some structural complexity development with light environment from the overstory and midstory. Towards the left of the screen here was more of a reserve area to more of a heavier thin on the right. And in the midground, you'll see a lot of that is paper birch regeneration, as well as even white pine regeneration in the foreground. This is just a quick picture of the TNC study plot in 2019. They just recently brush sawed it. And overall, it's doing really well with their both red oak and bur oak, and that jack pine in the middle is about 5 feet tall. So I think in terms of overstory, what we really did, we were successful in turning the species dial heavier to white pine, which I think fits pretty well with the overall succession pattern of FDN 43. And with that diversity of canopy structure and light environment, I think we did do a good job of meeting some of those structural diversity goals. But with some of the hardwood regeneration and that we had in paper birch and also white pine regeneration, I think we are working closer within the bounds of some of those natural succession pathways we see in FDN 43, even though I think we have a lot to learn with that native plant community. And perhaps what I think was the most interesting about this whole thing, regen was not an explicit objective because we marked this treatment as a thinning, but going back in 2019 gave us some really interesting results. Amongst all that brush we did see, it was spatially variable, but what was really remarkable was just the amount of natural white pine regeneration as well as natural paper birch regeneration amongst different gap sizes. And our follow-up stand exam plots was nothing fancy in terms of statistical design, but we are picking up things like red pine regeneration, white pine, paper birch, northern white cedar regeneration, along with red maple, even some jack pine and white spruce. So that was really interesting to us. And this is happening in year 7. And normally we just take our stocking surveys to year 5 to certify a normal stand. So regeneration is continuing to happen. And as you can expect, most of that regeneration is happening on skid trails, dozer lines, and the areas of balsam crushing we did for the line prep to make it, we thought that, most of that happened during that prep we did for the prescribed fire. You know, I'm not going to talk too much to the TNC study, but I do think it's interesting. I'll direct folks to this publication that came out this year by Julie Ederson, Mark White, and that TNC. This was one study site of a larger study. And it looked at bur oak and red oak planted from two different seed zones. And overall, the study site had higher growth and survivalship of bur oak and northern red oak from one seed zone to the south. And aside from the study in general, I do think this was interesting just from a silvicultural perspective of it represents strategies in the climate change adaptation toolbox of increasing stand diversity with climate winners for this region. And beyond the study, I think that will continue to serve this particular site. So some lessons learned. What I valued out of this was it demonstrates that we can use active timber management in some of these old mixed stands within the silvicultural system to maintain stand complexity. But you know, what do we call this? And I ended up calling it a variable retention harvest, that's what actually it turned out to be, because we had these variable sized pockets that we are regenerating portions of the stand in. And I do think there's some gradient of different tools that are out there now, like variable thinning, variable density thinning, and even a regular shelter wood that can help get at some of these same goals. But I think that's what fit the system and the prescription here the best. And in terms of prescribed burning, I just think we have been doing it more effectively on other sites, that be it layout, be it other prescription complexities. I think we've learned a lot of lessons in how we lay out our stands from a timber perspective so we can burn them better and maintain our overstory pine component. But markedly for me, you know, having a bit more faith in natural regeneration, you know, over here on the shore, we have more mesic sites. We don't put a lot of faith in natural regeneration, and brush is very much an issue over here on mesic sites. But at year 7, like I said, it's still coming in. So where I think mechanical site prep and even tree release needs to be seriously considered, you know, maybe that could be offset, the cost of that could be offset by the fact that we're not planting. Or, you know, our partners are interested in doing some of that work with us that would meet some of their goals as well.
Kyle, you've got about a minute and a half left.
Copy that, thank you. And it's great for this site to have a basis for one assisted migration study that gives us context for how we may incorporate more assisted migration in the future. We're not doing any actively on the forest operationally, but we are working with our SO and our region to come up with a forest-wide adaptation, assisted migration plan, how we actually get that implemented on the ground with input from geneticists and partners. And again, with adapted silviculture for climate change, I thought it was really interesting that we had the oak on this site and promoting additional stand diversity. And lastly, just to be able to document the changes and follow up. The only reason I was back here was I was introducing some variable thinning prescriptions in another project. And I was told, well, do you have any pictures? What does this look like? And I said, well, I don't know. So that's why I was out here and I started looking around, and I thought there's something going on I want to look into. So I appreciate the Great Lakes Silviculture Library that, you know, it's always been kind of poking and prodding of, hey, do you got anything interesting and that should be interesting in looking into? And I'm really glad I was able to do that and check it out. So with that, Nate Thompson was a forester that collected the data out here. I was really thankful to him, and for certainly the Nature Conservancy one for the research, as well as just the partnership that they're doing on the forest, and they're continuing to be a big partner in our management out here. So thank you.